Hi students, welcome back. In this video, we're going to do some O-level questions on the topic of logarithmic functions. Alright, so the first questions we'll be doing from the year 2021, that is not long ago. Right, so we're supposed to show that the solutions of this equation is given to be this. Right, supposed to solve the equation that it's been underlined, and the solution is the one that's been circled. Alright, so what I'm going to do is I'm going to present to you two different methods of solving this question, and then you can decide which method you prefer. Alright, let's look at method number one. So for method number one, what I've done here is I actually bring common log to both sides. Alright, and on the right hand side, we can actually apply the product law. Okay, for your logarithmic functions, log bracket n m times n gives you log m plus log n. And then the next step is we apply the power law. Okay, the power law, we can just bring down the power, and that will gives you x log 6 equals to log 5 plus bracket x plus 1 close bracket times log g. The very important thing to take note of is to, yes, you need to bracket your x plus 1. Right, it's very important that you bracket the x plus 1, because if you don't bracket it, this is what happened. If you bracket it, it means we are getting log 3 to multiply with both terms, x plus 1. This one, if you were to simplify it, it will give you x times log 3 plus log 3. Okay, but if you don't bracket it, this is what happens if you don't bracket it. Basically, it's just x plus log 3. And of course, x plus log 3, it's not the same as x log 3 plus log 3. All right. Therefore, you have to bracket it. Okay, let's continue. Okay, and then we will group all your x terms together, put it on the left hand side. Wait, I'm going to erase this so that you can see clearer. And we're going to factorize x out from the left hand side. And on the right hand side, we're going to apply the product law again. On the left hand side, we can apply the quotient law, as indicated there on the screen. Then the right hand side, we can apply the product law. Alright, so we have x log 6 divided by 3 equals log 15. 6 divided by 3 is 2, so therefore x is log 15 divided by log 2. Alright, I make a typo error here. This should be log 15. Okay, which is exactly what we're supposed to show. So this is method 1. Alright, I'm going to show you method 2. So for method 2, I won't be bringing log to both sides. I'm going to do some simplifications using the rules of indices that we have learned earlier. Yes, okay, we're going to apply a to the power of m plus n equals to a to the power of m times a to the power of n on the one that I've circled. And then I'm going to rearrange. That means I can basically take 5 times 3 here, put them together, and that will give me 6 to the power of x equals to 15 times 3 to the power of x. The next step is I'm going to bring the terms with the power x together, put it on the left hand side. So I'm going to divide both sides with 3 to the power of x. The next thing is that I'm going to apply, yes, this another rule that I've learned earlier on. A to the power of n over b to the power of n will gives you bracket a over b to the power of n to simplify the 6 to the power of x over 3 to the power of x, and that will give us, yes, bracket 6 over 3 close bracket to the power of x, and here the 3 to the power of x can be cancelled off each other, leaving only 15, and 6 divided by 3 basically is just 2, so we will end up getting 2 to the power of x equals to 15. Then the next step here, then I will bring common log to both sides, and then I'll have to apply the power law, bring the x, yes, apply the power law, bring the x to the front of log 2, and divide both sides by log 2. So this is the second method of solving this question. Yes, so which method do you prefer? Okay, let's look at 1b. So if you look at 1b for such a questions, the number of marks that will be awarded is 4. Right, so let's see how many steps are involved in solving these questions that they're awarded 4 marks. If you were to examine the questions, you'll see that they have different bases. One is base 3, one is base 9. So here that gives you an indication that you have to apply change of base. So therefore, let's do a recap on the formula to use for changing of base. So let's say if you have log base A, B, and if you want to change it to log base C, right, so we have a fraction, so that's right, log first at the numerator, log at the denominator. So let's say if you want to have base C, right, so just put the C there, the base there, make sure the size is much smaller than your log. Then the original base will go to your denominator, and then B will go to the numerator. Okay, so this is how you change base. So now the next thing that you have to decide is, should I change base 3 to base 9, or should I change base 9 to base 3? Okay, so usually I would prefer to change the bigger one to the smaller one. Change the bigger one to the smaller one. Right, so let's see how we do it. In other words, I keep base 3 as base 3. And then for this one here, I'm going to change it to base 3. So I will have log base 3 bracket x plus 2, and then log base 3, the original base is 9, go to the numerator. Okay, I'm going to simplify further. Right, so I can write 9 as 3 to the power of 2. Right, let's simplify further. Apply power law to this, so you can bring your 2 down. So you have 2 times log base 3, 3. The numerator is log base 3 bracket x plus 2 equals to 2. That will give you log base 3x plus half log base 3x plus 2. Alright, so I'm going to multiply by 2 on every terms. So I would have 2 log base 3x plus log base 3x plus 2 equals to 4. Okay, and then the next thing is that I'm going to apply power law to this. So I would end up getting log base 3x squared and this, of course, I can apply my product law. So applying the product law, I would have log base 3 x squared multiplied with x plus 2 equals to 4. Right, and the next thing is that I'm just going to convert it into the index form. So to convert it into the index form, zoom into your base. So it's 3 to the power of 4 equals to x squared multiplied with x plus 2. Let's simplify this one to get x to the power of 3 plus 2x squared equals to 3 to the power of 4 gives you 81. And if you're going to bring everything to the left hand side, you will have x cubed plus 2x squared minus 81 equals to 0. And this is the cubic equations that the questions require you to find. Right, so for these questions that summarize where the 4 marks will be, which steps will be given the marks. Right, so 1 mark will be given to this part here where you need to perform change of base. And I suppose 1 mark will be given to this here when you need to simplify it. And then of course 1 mark here to apply the product law. And finally, of course, 1 mark for the answer. Alright, so the next question is that supposing I do not wish to change it to base 3. I want to change it to base 9 instead. Right. So what do you think the solution would be? So let's do it. So supposing I'm going to change it to base 9. Okay. Right. So here it's a bit tricky. Okay. This part here is a bit tricky. Right. So you have to think of it like, because you're using base 9, right? So I have to write 3 as base 9 to the power something. So in this case here, it will have to be half. 9 to the power half. That means square root 9. 9 to the power half means square root 9. Square root 9 gives you 3. So you have to write 3 as 9 to the power half. And then the next thing is to apply your power law, bring the half down. So you end up getting log base 9x over half. Log 9 base 9, which is practically 1. And you have log x base 9 divided by half. That will give you 2 log base 9 x plus log base 9 x plus 2 equals to 2. And then from there you can apply the power law, and it will be similar. The following steps will be similar to what we have done here, and here. So you will still get x cubed plus 2x squared minus 81 equals to 0 in the end. You still get it. Right. The only part that is difficult to manage is this one here, because if you were to change it to base 3, it's easier to convert 9 as 3 squared. Okay, but if you change it to base 9, then you have to write 3 as 9 to the power half. It's slightly harder. Right, but whichever methods, you will still get x cubed plus 2x squared minus 81 equals to 0. Alright, let's look at question 2. So for question 2, I am going to show you one common mistake that some students may make in trying to manage this question. Yes, and some students may just bring common log to both sides. And then this is what some students may do. Okay, right. So the danger of doing such thing is you did not apply the product law correctly. Okay, on the left hand side, yes, it's an incorrect applications of the product law. Okay, remember that log bracket A plus B is not equal to log A plus log B. The correct product law is log bracket A times B, that gives you log A plus log B. So if you were to bring common log to both sides on these questions, you can only apply the product law to the one that's colored in blue. Then the one that's colored in yellow, you can't apply it. So therefore, you can't actually solve this question by bringing common log to both sides. Okay, I hope you understand what I'm talking. So what is the correct way of doing it? Yes, the correct way of doing it is to use a substitution method. And that is when you let e to the power of x equals to a. And e to the power of negative x is equals to 1 over e to the power of x. If you were to recall this particular rules that you have learned, in the chapter of indices. So therefore, e to the power of negative x is 1 over e to the power of x. And since you have let e to the power of x equals to a, that gives you 1 over a. So if you rewrite the equations, you end up getting 3a plus 5 equals to 2 times 1 over a. And we're going to multiply both sides with a. So you end up getting 3a squared plus 5a on the left-hand side. And 2 times 1 over a times a, and that just gives you 2. And if you bring everything to the left-hand side, you actually end up getting a quadratic equations where you can just factorize it. And you will get two values for a, which is 1/3, or a equals to negative 2. So what happened is when a is equals to 1/3, e to the power of x is equals to 1/3. And here we have to bring natural log to both sides. Okay, because natural log is just log base e. Right, so if you bring natural log to both sides, what we are having is log base e to the power of x. And you can apply the power law here to get x log base e, which is 1. So x times 1 just give you x. So that's the reason why we bring natural log to both sides. And you have x equals to negative 1.1 because you're required to put your answer to two significant figures. How about the other values when a is negative 2? You will end up getting e to the power of x equals to negative 2, which you have to reject it because there will not have any values of x such that e to the power of x equals to negative 2. Because basically e to the power of x is exponential functions and it's more than 0. Alright, so you have the left hand side more than 0 and the right hand side less than 0. Okay, so therefore it does not make sense. It's not equal. Okay, positive is not equal to negative. So therefore e to the power of x equals to negative 2 has to be rejected. So this is how you solved this question 2. Right, let's look at question 3a. So 3a, basically we're using the same concept as what we have done earlier. We're going to use substitution method. Substitution method, it's a very, very valuable method. Okay, it actually bring you, when you use substitution method, it actually bring you to the situations that you are familiar with, that you're comfortable with. What do I mean by saying that? So for this questions, if we're going to replace e to the power x with the letter a, let's see what happens. You end up getting a times 1 plus a equals to 3/4, right? Right, and can you see that you actually end up getting a quadratic equations that you're familiar with? And a quadratic equations, what do? You factorize it. And from there, you can find the values of a, which is -3/2, or a equals to half. But since a is a substituted values for e to the power of x, remember to replace it back. And as what I've explained earlier on, if you have e to the power x equals to -3/2, you have to reject this because there is no solution for it. However, when a is equals to half, right, e to the power x is equals to half, there is a solution because both sides are positive. E to the power x is more than 0, half is also more than 0, so there is a solution for it. So we're going to bring natural log to both sides. Apply the power law, and therefore x is -0.693. Okay, let's look at part B. Right, before we actually do part B, I just want to remind you folks that the danger of some of you folks may tread on. What's the danger? Yes, okay. Log base 2 bracket y plus 3, it's not equal to log y plus log 3. Okay, remember. Right. And another thing that to solve this question is another concept that we need to revise on is this. It's more or less a shortcut. Supposing I'm going to change log b base a to log b. Let's see what happens. Right. So log b base b will give you 1. So can you see the shortcut there? Meaning, if I have log base 2, 3, that is equals to 1 over log base 3, 2. Let's try another one. If you have log base 5, 6, that is actually 1 over log base 6, 5. And this is very useful. It's a very, very useful shortcut, which we're going to use it on our this particular term here. Right, to change it to log base 2. Right, so basically 1 over log base 8, 2 is actually just log base 2, 8. Okay, and then the next step is I'm going to change this 1, rewrite 1 as log 2 base 2. Okay, because log a base a is 1. So therefore log 2 base 2 is 1, or log base 3, 3 is 1. So I'm going to rewrite 1 as log 2 base 2 because base 2 is the one that we're using throughout. And then apply the product law on the left hand side. Which will get log base 2, 2 times y times 8 equals to log base 2 bracket y plus 3. Okay, I'm going to erase this off so that you can see clearer. So basically you have log base 2 on both sides. So therefore you can just compare this one, which gives you 16y equals to y plus 3. Bring all your y's to the left-hand side. That will give you 16y minus y, give you 15y equals to 3. Divide by 15 on both sides, you'll get y equals to 1 over 5. And 1 over 5 is more than 0, so it's all right. Okay, let's look at part C. So part C may appear to be a bit challenging or a bit frightening, or what's the word used? Intimidating. But actually it's not so frightening because what the question require you to do is usually you will have a curve and then you ask to draw another straight line, right? And the intersection points of the curve in a straight line will be the solutions to solving this equation. right? And the questions is not frightening because the question exactly asked told us what to do, and that is to make e to power x over 2 the subject. Means you're supposed to work on this, do some work on it, and finally make e to power x over 2 on the left hand side equals to something on the right hand side, and that right hand side guy will be the equations of the straight line. And no, not the equations of a straight line. After you make e to the power x over 2 equals to something something, you can just manipulate it to find the equations of a straight line. Okay, so having said that, let's go about doing it. But before that, okay, something very important, and that is we need to convert your ln to log base e. Ln is natural log, and we need to convert to log base e. Why do we need to convert to log base e? Because yes, we're going to convert it into the index form. Okay, so the base is base e, so e to the power x is equals to this. Alright, so something good about equation is that if you were to do some actions on the left, make sure you do it on the right, and as long as they're balanced, you're fine with it. Okay, you have not broken any mathematical rules. So what we're going to do here is I'm going to multiply the power on both sides with half, and let's see what happens. Yes, and you end up getting e to the power half x on the left hand side, and just 2x plus 7 over 3 on the right hand side. So here we have make e to the power half x the subject. Then from there it says hence find the equations of a line. Okay, so I need to do some manipulations. So basically I need to do some additions to here to get this one here. Okay, so I need to multiply 3 on both sides, because if you look at what I've just circled for you, okay, I have 3 e to the power x over 2. So I need to times 3 on both sides to force out my 3 e to the power x over 2. Right, so I have now 3 e to the power half x equals to 2x plus 7. And that's still not enough, because if you go back to your curve, I need a 4 there. So I need to add 4 on both sides. Right, so what happened now? You will see that I'm going to replace this one with y. So therefore, the straight line that I need to draw is y equals to 2x plus 11. Okay, and this is how you solve part C. Okay, so for this questions here, it's something quite similar to the formulas that we derive from compound interest. But in this case here, it's instead of increasing, when the values get bigger and bigger, in this case here, it gets smaller and smaller. Okay, because that is the aim of it. Okay, because this is a disinfectant company, and you to make products valuable, obviously your germs will have to get less and less, right? Can you imagine if you buy something, you want to kill the germs, and instead of killing it, you actually multiply it, right? Okay, so how do we go about solving it? So what we have done here is we can start off with 0 minute. So when t is 0 minute, number of germs present is n. That is when you have not started to use your disinfectant. Okay, so there are n number of germs in the house. Okay, so you start to use this disinfectant. So 1 minute later, what happened? correct, 1 minute later, right, 21% of, you will queue 21% of it. So what is left will be 100 minus 21%, right? What is left is 100 minus 21% over 100 times n. So you're left with 0.79 n germs. It must get less and less, right? Then you continue using it for another 1 more minute. So when n is 2 minutes, okay, from your 0.79 n, it reduces another 21%. So it becomes 0.79 times another 0.79 n. And it keeps going on until t is n minute. Right. And you will see that you will have 0.79 times 0.79 times 0.79 to the n times, and that will give you 0.79 to the power n times your original number of germs. And that will be the formula. That will be the formula for you to find the number of germs expected to be alive after you use the disinfectant. Okay, so the manufacturer is trying to increase sales, right? So he decides to tell people that, if you use it for 20 minutes, right, it's able to destroy X% of all non-germs, right? So you need to calculate, after using it for 20 minutes, what is the total number of, what is the percentage of germs that would be killed? My goodness. But can you imagine, in the 20 minutes, you may be also inhaling in all the, I don't know, maybe you should wear a mask so you don't inhale in all the disinfectant also. All right, so let's go back to part A, where, do you remember the formula to find the remaining number of germs left? That is 0.79. Yes, the number of germs present after n minutes, 0.79 to the power n times n, which the capital N, okay, this capital N is your original amount of germs in the beginning, but this small n, it's the variable for time. So we're going to substitute n equals to 20 minutes, okay? And what else do I need to substitute? And the number of germs present. Okay, because it says that you destroy X%. So if you start off with, let's say, 5 germs, 5, and if you destroy X of them, so how many is left? So isn't it 5 minus X over 100 times 5? Okay, let me explain again. Supposing you start off with 10 germs, all right, and if you destroy X of them, so X over 100 times 10, you destroy this amount of them, and you have 10 in the beginning. So what is the remaining? So the remaining will be whatever you have in the beginning, which is 10 minus away what you have destroyed, right? So this will be your left over, right? Which is what I have here. Okay, the number of germs present. This is the one that is being destroyed already. This is the original amount. So what is left will be just original amount minus what you have destroyed. And I'm going to factorize the n out. And this value is exactly equal to this guy, because this formula that we got in part A, okay, this is the number of germs present, left. Present means left after n minutes. So I'm going to equate both of this and see what happens. Yes, and you can just cancel n on both sides, the capital N. You substitute your small n to be 20 minutes, and then the big N can be cancelled off on both sides. Okay, and then simplify further. Right, use your calculator, and you'll get X is equals to be 99, because you're supposed to express it to two significant figures. Oh my goodness, after 20 minutes, you can literally kill 99% of all the germs. It's still not 100%, but 99 is already good enough. Okay, right. All right, so part C, what happened now? So we have part A where we find the formulas to calculate the remaining number of germs left. We have part B that said 20 minutes later, you can actually kill 99% of all the germs. And part C, you're supposed to find a constant K. Okay, so you're given this formula here. This one, it's the formula that number of germs expected to be alive. That means number of germs that is left lah, which is this formula that we have found earlier on. So basically, these two are the same. They're talking about the same thing. So you just equate them. And you can just take away your n on both sides. Right. And I'm going to bring natural log to both sides so that it can apply the power law. Okay, and again, can you see that the small n can be cancelled off again? So left only k equals to ln 0.79, where you can just use a calculator to work out the values to be negative 0.236. Okay, let's look at the next questions, November 2019. Okay, this one is relatively easy, really relatively easy. All we need to do is just to substitute. Yes, 8, 3. 8 is your x coordinate, 3 is your y coordinate. Just substitute into your logarithmic equations. And then convert it into the index form. Write 8 as 2 to the power of 3. So you have the same power, therefore the base must be the same. So a is equals to 2. Okay, so this is relatively easy. So after finding the values of a, you can substitute into your logarithmic functions and also substitute 1 comma b to find the values of b. B basically it's the value for your y coordinates. So what is log 1 base 2? Log 1 base 2, it's 0. So therefore b is 0. Okay, then to find the values of c, same thing, just substitute a equals to 2. C will represent the x coordinate. Y coordinate is negative 2. Convert it to index form again. Oh, so for these questions here, that's why in the beginning when you learn logarithmic functions, you must know how to convert from log to index and index to log. That's the most basic things. You have to know that first, okay? Right, so convert it into index form is base 2. So 2 to the power negative 2 equals to c. Alright, so 2 to the power negative 2 is 1 over 2 squared. That gives you 1/4. Okay, very good. We have done part A. So part B, sketch the graph. So now we know that your A is equals to 2. So we are sketching the graph of y equals to log base 2x. Okay, right, so this is how it looks like. Okay, let's look at the next questions. Okay, now we're going backwards. So we started off with 2021, then 2019, so now it's 2015. Okay, so for these questions here, what are we supposed to do? We are supposed to express it as a quadratic equation in x and explain why there are no real solutions. Okay, so first part, let's apply the power law. Right, so basically if you were to recall all the questions we have done so far, you really need to make friends with all your 3 laws, the product law, the quotient law, and the power law. So here we apply the power law. Then the next thing is apply the quotient law. And convert it to index form. Simplify it. multiply by x minus 4 on both sides, and you end up getting a quadratic equations. Okay, so the next step is, why is this quadratic equations has no real solutions? Okay, there are two ways of solving it. You can actually use your quadratic formula to solve this, and then you will get a square root of a negative number, and then from there you can explain that there are no real solutions. Another way is, if you were to recall what I learned long time ago, actually not really long time now, it's just in January, you learned chapter 1, quadratic inequalities discriminant. So we can use b squared minus 4ac to verify whether if there's any real solutions or not. So let's go ahead and find the values of b squared minus 4ac, and we get negative 64, which is less than 0. So therefore the equations has no real solutions, no real roots, so no real solutions. Okay, so we are done with 6a. Alright, so with 6b, we're supposed to make y the subject. So basically you're supposed to get rid of all the log. Okay, get rid of all the log and just y equals to something in terms of x. Okay, how do we go about doing it? Yes, this one we will have to apply what I think one of those questions, is it 2021? No, this one here. Oh, I think I have a recap. Yes. Okay, this recap here, to remember the shortcut there, we say is very useful. So basically I'm just going to change this one, log x base y equals to 1 over log y base x. Okay, why I want to do that? Let me explain to you why I want to do that. Yes, so that just to make all of it having base x, okay, in the same form, right, in the same form. And then the next thing is I'm going to use substitution to make the thing more manageable and to convert it into a quadratic equation. Yes, right, to find the values of a, you cube root negative 8. Cube root negative 8 will give you negative 2. Right, so a is a substituted values for log y base x, so you have to put it back. Then convert it into index form again, so x to the power negative 2 equals to y. So therefore y is equals to 1 over x squared, or x to the power negative 2. Okay, if you're losing steam, don't give up, because this is the last question, okay, in this video. Right, so if you look at 7a, we have base 2 and base 16, so that gives an idea that we have to apply change of base. Alright, so I'm going to change base 16 to base 2, because I can write 16 as 2 to the power 4. Okay, I have a recall there on how you can actually apply change of base. And then apply the power law again. Right, so from here, you will get log 2 base 2, which is 1. So this will give you log base 2x over 4, and you can write it as 1/4 log base 2x, which I have it here. Okay, I need to erase this one because I need space for the solution later. Okay, and then multiply by 4 throughout. Okay, what I have done here is times 4. 1/4 times 4 will just give you 1, and then times 4. Okay, so that will gives you 5 log x base 2 equals to negative 10. Divide by 5 on both sides. Yeah, and then convert to index form. So x is equals to 2 to the power negative 2, which is 1/4. Alright, so can you see so far what we have been doing? It's you must know the 3 laws very well. Product law, quotient law, power law, also change of base. Must know how to change from log to index form. Okay, and then must also know that natural log ln is log base e, lg is log base 10. All right. Right, let's look at B part I. B part I, it's rather manageable. You just need to apply quotient law on the left hand side. And since we have log on both sides, you can just cancel them. Right, and then the next step, you just multiply by y on both sides. Okay, and then expand this. And then group the terms with z. Put it on the left hand side. And factorize z. Yes, and divide 1 minus y on both sides. And that's how you make z the subject. Okay, so that it's B part I. B part 2 state the range of values of z. So if you were to go back to your original logarithmic functions, for z to be defined, for log z to be defined, z must be more than 0. Okay, and we know that z is equals to this fraction here. And y squared, it's a positive value, because when you square something, you get positive value. So therefore, your denominator must also be positive, because positive divided by positive then give you z to be positive, right? So therefore, 1 minus y must be more than 0. So therefore, negative y is more than negative 1. So y must be less than negative 1, because when you multiply both sides of an inequality with a negative, you need to flip your inequality sign. And then if you go back to the original equations, you have log y there. So for log y to be defined, y must be more than 0. So if you combine both of these conditions, y has to be more than 0 and less than 1. Okay, so this conclude this conclude this video. We have finished doing all the questions in this video. Okay, this is quite a taxing piece of work, right? So if you find it very heavy going, you can just break it up, take a break in between, and then come back again to finish up the remaining questions. Okay, thank you.